Namo Buddhaya. Dear children, this lesson is for the local O-level students to teach you how to read the trigonometry table and use these values to do questions. Okay, so children, before we learn how to read the trigonometry table, we have to learn about how to measure an angle. So you already know how to measure an angle quite well. You know that you use degrees to measure an angle. So children, we know that a circle, a full circle is divided into 360 minutes, 360 degrees, right? But children, a single degree, right? You know, a single degree is a very small amount. A single degree can be further divided into 60 minutes, right? A single degree can be divided. So you can imagine this is going to be very, very small divisions, children, right? So a single degree can be further divided into 60 minutes, and children, the notation for this is 60 and an apostrophe, or 60 and a dash. That's how we write minutes. Okay, so here children, I have taken a degree in this diagram. So although we say I've written it as 1 degree, children, so obviously this is not 1 degree, this is a very big angle, right? But I have shown it as 1 degree because I want to exaggerate and show you how this 1 degree can be divided into 60 parts. If I took an actual 1 degree angle, you won't be able to see it, right? So first children, let me divide it into 6 parts, right? If I divide it into 6 parts, children, you can see this will be 0, 10, 20, 30, 40, 50, 60 minutes, right? But each of these subdivisions can be further divided into another 10 parts, children. So for example, let's take the section between 30 minutes and 40 minutes. So that will also have another 10 subdivisions, children, right? So therefore, in total, in 1 degree, inside a tiny degree, you will have 60 subdivisions, right? So we will count the subdivisions as 1, 2, 3, 4, so on. So the subdivisions between 30 and 40 minutes are going to be 31, 32, 33, and so on. Right, so remember children, now from now on, when you measure angles, you can measure in degrees, and within the degree you can even measure to a higher accuracy with minutes. Okay, right children, so now let's go to reading the trigonometry table. Right, so I'll show you what the trig table looks like. So children, this is the trigonometry table, right? So this is 1 page of the trig table, right? So children, now remember, there are 3 trigonometric functions: sine, cos, and tan. Children, when we are reading sine, okay, when we are reading sine angles, right, we use this column and these 2 rows, right? But when we are reading cos, we use this column and these 2 rows. So remember that, children, right? For sine, we use the red ones. For cos, we use the blue ones. Okay. Then children, for tan, right? So here is a page of the tan table. For tan also, we use these columns and rows, right? Ignore this one, this cotangents thing at the bottom that you find of your trig table. We don't need it, right? We only need sine, cos, and tan. Okay, now children, let's look at how we can actually read this table. All right, now here I have a zoomed in view. Okay, so now children, we'll first learn how to measure some sine angles, right? So we'll start with, say, sine 17 degrees. Right, so children, this is very easy to read, right? So you can see, so let me scroll down a little bit more, right? So you can see I have the angle 17 degrees right here. So children, there are no minutes in this angle, just 17 degrees. Very easy to find the answer. It is 2924, 0.2924. Okay, so this is equal to 0.2924. Okay, but let's make this a bit more difficult. How about sine 17 degrees and 20 minutes? Sorry, not 21, 20 minutes. Okay, 17 degrees and 20 minutes. Now the way that you would find this is, now we found 17 degrees. Now children, look at the column for 20 minutes. That's this one. Okay, so you find the corresponding position for 17 degrees and 20 minutes, meaning this position would be over here, children. So that means sine of 17 degrees and 20 minutes is going to be 0.2979. Okay, so this angle, so this value is going to be 0.2979. Okay, but let's take it one more step, right? So let's say you have sine 17 degrees and 24 minutes. Now things are a bit different, because now you can see there's 20 minutes, there's another column for 30 minutes, but where is 24 minutes? Children, we go to this other side where you find the mean differences. And do you see the column with 4 minutes, right? So you go to that corresponding row, right, over here. Okay, so you can see the value is 11, right? On 17 degrees the value is 11, right? So to find 17 degrees and 24 minutes, you have to add 11 to 2979. So children, 2979 plus 11 becomes 2990. 2990. So that means, children, sine 17 degrees is 0.2990. This is how you find the values. All right. So children, now let's also look at some cos values. Okay. So let me scroll down. Okay. So here we have the cos values. Now we look at the other end of the table, right? So let's take some cos values. We'll take cos 58 degrees. So children, when we are looking for 58 degrees, this is quite easy because 58 is here straight away. There are no minutes, right? So that means, children, this is the value, 0.5299. Okay, but what if you had cos 58 degrees and 10 minutes? Now children, just like before, you have to go to 10 minutes. So remember, here we are looking for minutes from the bottom, right? Not from the top where we look for sine. Okay, so that means, children, cos 58 degrees and 10 minutes is going to be this value here, 0.5275. Okay, so this is equal to 0.5275. Okay, but let's take it another step. Let's say you have cos 58 degrees and 16 minutes. Now what do you do? So you saw earlier what we did, right? So you have 10, you have 20, you have to add 6 to 10. Okay, you have to go to this column here, right? You have to go to 6, and you can see the corresponding value is 15. But children, there's a catch. Remember, for sine and tan, we add the mean difference. For sine and tan, we add the mean difference. But for cos, children, we subtract the mean difference. We don't add the mean difference. We subtract it. So remember, from 5275, you don't add 15. You subtract 15. That gives you 5260, right? So this answer is 0.5260. That is how you find the cos value of 58 degrees and 16 minutes. Okay, let's also take some tan values, children, right? So we'll go to the tan table. Okay, so here we have the tan table, children, right? So in the tan table, we'll start with, we'll take tan 10, right? So we want to find tan 10 degrees. Okay, so tan 10 degrees, children, is going to be quite easy because there are no minutes. So tan 10 degrees is 0.1763. 0.1763, right? But if we have tan 10 degrees and 30 minutes, what do you do? So then, just like before, you go to the 30 minutes column, right? And you move your value. You take the value at 30 minutes. 10 degrees and 30 minutes is 0.1853. You can see how I got the value. But let's say you want to find tan 10 degrees and 35 minutes. Now what do you do? So you can see we have 30 and 40, we don't have 35. So you go to mean differences, right? And you find the column for 5. And you can see that my corresponding value here is 15. So that means, children, now for tan also you have to add the value, right? Only for cos you subtract the value, right? So we have 0.1853. So to 1853 you have to add 15, children. So that gives you 1868, right? 0.1868 is going to be our value for tan 10 degrees and 35 minutes. So children, now I hope that it's clear how you should read this table. Okay, right. So children, now let's go on to some questions. So I'll show you how to do a few questions using these, right? Okay, so children, let's look at this first question. So we have the angle in focus is 20 degrees, the opposite is x, and the hypotenuse is 5. So the function that the trigonometric ratio that uses opposite and hypotenuse is sine. So children, sine theta is equal to opposite to hypotenuse. In this case, sine 20 is equal to x over 5. You take the x to the other side with the sine 20, meaning you multiply both sides by 5, right? That gives us x equals to 5 times sine 20. Now children, you have to go back to your table and find the value of sine 20. So let's go to our table now, right? Let's go to the table and try to find the value of sine 20, children. So sine 20, okay, so you can see here, right? So this is, let me just check if this is sine. Yes, this is sine. Okay, so sine 20, children, you can see 20 is here, sine 20, no minutes, so 0 minutes, 0.3420, right? 0.3420. Okay, so let's go back. Right, so then you replace sine 20 with 0.3420 and you multiply it by 5 and you get the length of x, which is 1.71 centimeters. Right, let's go to this other one. Now here we have minutes as well. So 50 degrees and 30 minutes is the angle, children. So this one you can see the adjacent is x and the hypotenuse is 17. So this is going to be a cosine, right? A cos ratio. So cos theta is adjacent over hypotenuse. So cos 50 degrees and 30 minutes is equal to x over 17 adjacent over hypotenuse. Right? So again we multiply the 17 with the cos 50 degrees and 30 minutes. You take it to the other side. Now we have to go back to our table and find the value of cos 50 degrees and 30 minutes. So let's do that. Right? So children, here is cos. Remember, cos 50 degrees is here, right? And cos 30 minutes is here. So the value for cos 50 degrees and 30 minutes is 0.6361. 0.6361. So now if we go back to our question, because we know the value now, right? So we substitute the cos value with what we found, 0.6361, and you multiply it by 17 to give us the answer. So that is the adjacent is 10.8137. So this is too many decimal places, children, so I'll just round it off to 2 decimal places. We have 10.81 centimeters. So of course, children, you will have to round it according to the question. They will tell you how many decimal places to round it to. Okay, let's look at another question. So this one, children, we have the opposite as 70 and the adjacent is x. So the trig ratio which uses opposite over adjacent is tan, right? So we're going to use tan for this one. So children, tan theta is opposite over adjacent and theta is 50 degrees and 17 minutes. So tan 50 degrees and 17 minutes is equal to 17 over x. Now children, for this one, I first take the x to the other side and I multiply it with the tan 50 degrees and 17 minutes, and now I divide both sides by tan 50 degrees and 17 minutes. So because remember, children, I have to make x the subject, right? So x is equal to 17 divided by, or 17 over tan 50 degrees and 17 minutes. Now I have to find, children, tan 50 degrees and 17 minutes. So let's go back to the table, right, for tan 50 degrees and 17 minutes. So let's have a look. So here's tan. This is on the second page of tan, right? So tan 50 degrees and 17 minutes. So children, you all know that for tan 50 degrees is over here, right? And 17 minutes, children, you have 10 and you have 20, so we land at 10, right? And this is the value, right? And you have to add 7 minutes, so that is from the mean differences, children, right? So from mean differences you add 7 minutes. So children, our value for 50 degrees and 10 minutes is 1.1988, and to 1988 you have to add 50. So 1988 plus 50 is 2038, right? Yes, 2038. So it's going to be 1.2038 is going to be our tan value, right? So you simply add 50 to 1988. Okay, so now that we have the value, let's go back to the question, right? And we'll replace the tan value with the decimal we found, and then you do the division, right? So that gives me the length of my adjacent, which is 14.12 centimeters, children. So now I hope finding an unknown side is clear. So let's go to finding an unknown angle, right? So children, here's another triangle, and we have the opposite as 5 and the hypotenuse as 7, right? So children, opposite and hypotenuse, we should use sine, right? So sine theta is equal to opposite over hypotenuse. So children, opposite is 5, hypotenuse is 7. First, children, I divide them and I find the value. 5 divided by 7 gives us 0.7143. Now children, remember, this is when you take sine inverse. So theta equals to sine inverse 0.7143, right? This is how you take the inverse. Now children, you have to search for 0.7143 in the sine table. All right, so let's do that. Let's go back to the table and try to find 0.7143. Okay, so here is the table. So let's go back to sine. All right. Okay, so children, it's on the second page of sine, right? So the number is 7143. Okay, so children, you can see on sine 45, on the row for 45, you have 7133 and 7153, right? So 7143, right, is going, you have to add 10 to 7133. So children, we always get the lower one and we add to that, right? So we stop at 7133, and remember children, you have to add 10. Okay, so when we add 10, children, we add from the mean differences over here, right? So that means children, our angle is going to be 45. 30 minutes plus 5 minutes, that is 45 degrees and 35 minutes is our answer. Okay, so that's how you find the angle. So let's go back to the question now that we found it, right? So now you can replace this with 45 degrees and 35 minutes because that is the angle, right? Now let's look at this triangle. So here we have the adjacent and the hypotenuse. We should use cos, right? So we'll replace everything. So 5 over 9. First you divide it. So children, this time it's an interesting one. We get 5556, 0.5556. You take theta equals cos inverse 0.5556, right? So now we have to go back to the table and find the value, right? So let's do that. Okay, so we'll go up to the cos section, right? So children, we have okay, remember the value is 0.5556. okay, so you can see we have 0.5544, oh sorry, 0.5544 and 0.5568, right? So children, remember, for cos we don't add, We subtract. So we go to the higher value and we subtract until we get 0.5556. Okay, so we don't go to the lower value. We go to 0.5568 and we subtract until we get 0.5556. So children, from 0.5568, you have to subtract 12 to get 0.5556, right? So from the mean differences, I subtract 12. So now if you try to look at what the angles are, we have 56 here, we have 10, right? Plus we have 5. So that means, children, the angle is 56 degrees and 10 plus 5 is 15 minutes. All right, 56 degrees and 15 minutes. So let's go back to the question again, right? So now we can write the answer as 56 degrees and 15 minutes. Okay, right, let's go to one last question. Okay, so children, we have this time we have the opposite and we have the adjacent. So children, we have to use tan theta is equal to opposite over adjacent. So opposite is 5, adjacent is 7, right? So again, I divide it, I get the value to 4 decimal places, 0.7143. okay, now theta is equal to tan inverse 0.7143. Okay, so let's go to the tan table and try to find the value of 7143. All right. Okay. Right. Right. So this is the tan page. Okay. Right. So children, you can see this is 0.7143. okay, so children, you can see that I have 0.7133 and 0.7177. so clearly for tan also we add, right? So we go to the lower value and we add. Now for 7133 is the value that we are going to pick, children, and to 7133 you have to add 10 to get 7143. Okay, so we go to the mean differences, and in the mean differences, children, you can see there's no 10. So we go to the closest value, which is 9. Right, the closest value we can get is 9. We don't have 10, right? So 7133 plus 9, that gives us 7142. That is close enough to 7143, right? So children, if we look at what these values are, right, the angle is 35 degrees, right? And now you can't see the column, but children, this is 30 minutes and this is 2 minutes. So therefore, children, the angle is 35 degrees and 30 plus 2 is 32 minutes. Okay, so let me go back to the question again. Right, and now we can replace this with the angle, which is 35 degrees and 32 minutes. So children, that is how you read the trigonometry table and use those values to find unknown side lengths and unknown angles. I hope all of you understood, children. Teruvan Saranai, Namo Buddhaya.